So in the rest of 4.1 we were going to look at angle conversion. So I'm doing this in part 2 video. And what we will be focusing on is making conversions from decimal degrees to degrees, minutes, seconds. And decimal degrees I'm going to short form with a DD, and we'll be taking them to DMS. Whoops. And those symbols look like degrees, minutes, seconds. So you might find this button on your calculator a DMS button, or it might be shown with the symbols. Okay, so you can have a look at your calculators. Decimal degrees to DMS, and then we will do DMS back to decimal degrees, and then recap on degrees to radians and radians to degrees. This I think has been covered in other sections, but it's covered here as well, so I'll just make sure that that's reviewed in this video also. Okay, so what is DMS? Maybe if you've ever looked at a GPS, for example, you may have seen the angles in DMS, degrees, minutes, seconds. Think about an angle, something like 12.5 degrees. So this is an angle in decimal degrees. This angle sits between 12 degrees and 13 degrees. And in DMS what the purpose is to break this division between whole degrees down into 60ths called minutes. Very much like we do with time. So, for instance, if you think of this as 12.5 hours, okay, so compared to time. And everybody's pretty used to that, so I think this is a good comparison to make. So 12.5 hours. Another way to state that is to say it in hours and in minutes. This is 12 hours. And a half an hour, well, 1/2 an hour is how many minutes? 30 minutes, okay? Now in degrees, we break the minutes down into seconds as well, just like we do with time. So I haven't given this to any more decimal places, but I just wanted to get you to think about how degrees broken down into minutes and seconds is very much like breaking hours into minutes and seconds. 60ths and 36 hundredths. So mathematically, how do we do that? Well, I've got 5/10ths of an hour. In a sense, this is my 0.5, right? And we would like to make that as an equivalent fraction in 60ths. So I've set up a proportion with equal fractions, and we just want to know what denominator over 60 is equal to 5/10ths, or 1/2. And you already know that that's 30, but let me just show you how you could figure this out if it wasn't such an obvious. We solve the proportion, set cross products equal to each other. 10x is equal to the other cross product, 5 times 60, 300. Divide by 10 to isolate x. That makes our 10s go away. And we get 30. Okay, a very quick method, because the same process is going to happen every time, is to take our decimal value, so we multiply the decimal value, the decimal part, by 60. You can kind of see that in this algebra here. If I wanted to isolate x, which is divided by 60, bring the 60 up to the other side, multiply both sides by 60. So 60 times 5/10ths, or 60 times 0.5. So we do 0.5 multiplied by 60 is our 30, which produces the minutes. So let me show you another example that will be able to take it into seconds. And just think about that, converting any decimal portion of minutes into seconds, we will also multiply by 60. Okay, so we're going to convert this angle, 42.3069 degrees. And just from talking about them earlier, you can probably see that this angle then sits somewhere between 42 degrees and 43 degrees. And it's that portion in between that we want to represent in minutes and seconds as opposed to decimal values. And let's make that conversion. Now, I said a little bit earlier, just take the decimal part and multiply by 60. And so that's what we will do. I'm going to make this into an angle that is in degrees, so the full number of degrees, and the rest will be the minutes, and we need seconds as well. Alright, so this part here, the degrees, is always the value before the decimal because it's the full number of degrees. The rest will be the decimal portion that we are converting into minutes and seconds. This is my minutes, this is my seconds, this is my degrees. Alright, so if we now take the decimal portion, 0.3069, and multiply by 60, we end up with 18.414. So that means 18 minutes, 0.414. Well, for the minutes, we just want the whole number of that. Just like we only use the whole number for the degrees, and we convert the decimal part into the seconds. So this is going to be our minutes. Then we will, alright, so we use that 18 here. Now we need to look at the decimal part, which will become our seconds. Alright, now there are 60 seconds in every minute, just like there are 60 minutes in every degree, so we'll convert it with the exact same multiplication factor, and I will take my 0.414, multiply by 60 to find out how many seconds that is, which is 24.84. Alright, now this number could go in as a 24.84. Generally what's happened is this is rounded to a whole number. A lot of calculators might take it to one decimal place, but either way that's fine. So rounded to a whole. And the closest whole number that is to is 25. So I'm going to call that 25. Alright. And the reason why it doesn't make too much difference here, think about this. We've taken our degrees and divided into 60 little parts. Then the 60 parts, each of those is divided into 60 little parts. So seconds, actually, there are 3,600. Alright, that's 60 times 60. 3,600 seconds in 1 degree. That degree is broken down into really, really small parts. So, whether I say 24.84 over 3,600 or 25 over 3,600, it's not making a big difference at this point. Now, you might think that why do we need to divide degrees into 3,600 little parts? This is important on a global scale, okay? So that's why this is used for GPS, and it's not used for really small calculations. It's used for very large ones. Okay, so that's our example. So 42.3069 is a decimal degree, and 42 degrees, 18 minutes, 25 seconds is in DMS. Great. So the big thing for that is going in that direction, multiply decimal, multiply decimal parts by 60. Okay? Next we will go in the other direction from DMS into decimal degrees. Okay, the second type we want to look at is converting DMS to decimal degrees. And so I have an angle here in DMS, degrees, minutes, seconds. Remember, this means that there are 16/60ths of a degree and 35/3600ths of a degree. So these are very small portions of this degree. This degree sits between 24 and 25. So we're looking for a 24 point something. So to add this up and find out what the decimal portion is, we will be able to do the math by looking at it this way. This is equal to 24 plus, okay, the whole number, the part before the decimal, plus. Now this fraction will be 16, and there are 60 minutes in each degree, so 16/60ths. And there are 3600 seconds, so 35/3600. When I convert these two fractions into a decimal and add them up, okay, so convert to decimal. How do we do that? Convert fractions to decimal, we just divide. So do the division and add the decimal parts. So it will look like this. 24 plus 0.2, it repeats the sixes, 6, 6, so I'm going to round that last one to a 7. I'm going to go 4 decimal places here. You can go further if you like, or leave them directly on the calculator. I just need to write it down to show you what's going on, but don't just round to a couple decimal places, because your 3600ths, this number is going to be very small. And if we only round to 2 decimal places, you'll probably end up with getting 0.001 or something. So make sure that you go 4 decimal places at least in this. Now, doing the division of 35 divided by 3600, that's a very small number, so 0.0097. Let's go that far. So these two decimal values, these are my fractions converted into decimals. We add them. They become the decimal portion of this degree. So this will be 24.2764, okay, degrees. So in a sense, to go in this direction, we're dividing by 60 for the minutes, dividing by 3600 for the seconds. So last time the direction was a multiply by 60 for both. Now we will divide minutes by 60, divide seconds by 3600. Alright, so that's your rule for going in that direction. Great. Okay, so lastly, I said I would just briefly review going over converting angles from degrees to radians. That is when we just take our degree angle and multiply by pi over, oops, not 360, pi over 180. Alright, and that will change it into a radian. And for the radians to degrees, multiply by 180 over pi. An example of that is take my 25 degrees times pi over 180. Just grab the calculator. Use the pi button whenever possible, and instead of just 3.14, multiply by pi, divide by 180, and I get 0. Let me find that spot on my little. Here we are. 0.4363. Going from radians to degrees, let's put an angle in radians. Let's say 1.2687 multiplied by 180 over pi. 1.2687 times 180 divide by pi. 72.69. All right. 72. Where is that? 72.69 degrees. If we round that to a whole, that's closer to 73 degrees. Thanks for watching.